Welcome to my YouTube channel Science and Innovative Brain. Today we will talk about what is the escape velocity. Okay, so we'll discuss what is the escape velocity. Okay, so what is the escape velocity? Escape velocity. What is the escape velocity? Escape velocity is defined as the speed at which any object travel to break free from either the planet's or moon's gravity and leave without any development of the propulsion. Means if we have two objects, you can say this is our earth and one more mass is there. Okay, so let us assume mass this m. So this mass is small m and this is capital M, earth mass. Capital M is the earth mass and this is the any other object, and it is kept at height h or h, and the radius of the earth is capital R. Okay, so radius of the earth is capital R. This is the center. Okay, so radius of the earth is capital R and this object is placed at height of h distance. Okay, so what is the escape velocity? Escape velocity means any object should escape from the earth gravity. Earth having some force of attraction, because any two bodies having the force of attraction as per the force of universal law of gravitational force. Okay, so according to that, this two body will attract to each other. Okay, so this having more volume or size and this is smaller, so this object, bigger object, will 100% attract the smaller object to their center side. Okay, so that is called one gravitational force. That is the gravitational force of attraction, and that force of attraction is as per the, I will delete this one. Okay, so according to universal law of gravitational, the force between these two objects, force is equal to G small m capital M divided by the distance between these two objects. So what is the distance between these two objects? Capital R plus h, from the center of earth and the height of this. So we can say capital R plus h is square. Okay, so this much force of attraction is between these two objects, earth, and you can say earth here. This is earth, we can say is earth. This is earth, our earth. Okay, so like how rocket is escaping, so we are telling na, it's our rocket should run at the speed of velocity of 11.2 kilometer per second. This is the escape velocity of the rocket. So same thing here, we will find out what is the escape velocity is coming for the earth to escape the object from the earth gravitational force. So this is the force of attraction between these two body. Okay, so this is the force. Okay, so in comparison, if we go for the derivation, we will neglect this h. See h here, h is very smaller than the radius of earth. Okay, the radius of earth is 6.371 kilo 3.67 into 10 की power 6 meter. Okay, this much is the radius of earth. So comparison to this h is very, very small, so we will neglect this. So what we'll find out, the f is equal to g capital M small m divide by, we will neglect this height, so this become r square, radius of earth. Okay, this is our one formula number 1. Okay, this is our formula for the force of attraction between earth and object. In this condition, the object is kept to earth surface here. Okay, because the height is become 0 because I neglected that height, and this object now came to this portion near to earth surface. So force of attraction at earth surface, so this is the force of attraction at the surface of earth. Okay, so force at earth surface. So this is the force at the earth surface. Okay, so we will find out the escape velocity. Okay, so for the escape velocity, this equation will write on top here. So F is equal to G capital M small m and r square. So here what is the value, what is the G? G is the universal gravitational constant. Okay, and the value of G is, capital G is equal to 6.67 into 10 to the power 11 minus 11 Newton meter square per kg square. Okay, yeah, this much is the, and what is the capital M? Capital M is the mass of the earth, Okay, we are taking with the help of earth only. So this is the mass of the earth, and small m is mass of object, which object is keeping, or any rocket or whatever. Okay, mass of object, mass of any object. Okay, and capital R is the radius of earth, radius of earth. Okay, radius of earth. Okay, so I am deleting this portion. We will take this equation 1 from there only. Okay, so to find out the escape velocity, it means if two object is there, or I will define here only, this object want to escape from the earth gravitational force. Okay, so this is earth, and here the object is there. This object want to escape without any if after the if it is in equilibrium, so it will not exit, it will not give any other extra force. With its momentum only it will get out from the earth gravitational force only. Okay, so here earth will pull that object to this side, inside the earth side. So this is one force, you can say earth gravitational force, and the small object will try to escape to other side. Okay, so that is the other force, you can say this is F2, this is F earth. Okay, these two forces will come in the picture when any object is coming to any near to planets. So this force of attraction will come, and the force of attraction of earth toward the earth, and this also having some force of attraction towards its center. Okay, so when the both force of attraction become equal, so this will become as a free object. Means this situation, the two energy is there, that is called, one is called kinetic energy and other is called potential energy. Okay, so one is called potential energy plus any object having potential energy and its kinetic energy Ke is equal to total energy of the object. Okay, or we can say this total energy of the object, E total. Okay, but in the case of equilibrium, in the equilibrium force of attraction, so both energy become equal. Okay, but here the potential energy, here the equation we written, but here what will happen, the potential energy is the direction of the potential energy is the downward and kinetic energy is the upward. So we'll keep this energy is a minus PE potential energy, because the direction of the potential energy is opposite to the kinetic energy. See, kinetic energy is this side and potential energy is this side, and this is the object. Okay, this is PE minus PE and this is KE, kinetic energy of the object. So this PE plus kinetic energy KE is equal to, in the case of equilibrium, when the both force of attraction become equal, then this energy become zero. See, potential energy and kinetic energy, potential energy and kinetic energy is become equal, then this become zero only. See, if P is, if you take the P is x and this is also x, so minus x. So if you add minus x plus x, what will happen? Minus x plus x become 0. Okay, so same we are writing here. Okay, so now we will put the potential energy. What is the potential energy? Potential energy is means mgh, force into distance. Okay, so what is the force? Force minus, that is opposite, we'll put the minus sign. Force into distance. So at the surface of the earth, we'll find out at the surface of the earth, what is the distance here of for that object? That is distance is r, that is r, and force is same force, this force only. Okay, so force into displacement is the potential energy. Okay, plus kinetic energy. This object is trying to move. Okay, so kinetic energy is what? Half mass of the object, this object mass, mv, velocity is square. Okay, half mv square. This velocity is called as a escape velocity. Okay, so I will write as a ve, escape velocity. This becomes 0. Okay, now we'll go force. What is the force? You can take from the force from the equation 1. In starting we told, I told as per the gravitational of the earth, r square. Okay, and multiply by this capital R plus half m is the mass of the small object, m, and its escape velocity square. This become 0. Okay, so this becomes 0. So what we'll do, we'll put, or we can say we can cut here. See, this formula again, if we solve, it will come, we will cut the r to r. So this become minus g capital M small m divide by capital R. See, niche r, down side r square is there, this is r, so this become capital R plus half mve square become 0. Okay, now we will solve this equation again. I am deleting this portion. Okay, so this, what will happen, we'll take this to this side. So half mv square, half mve square is equal to capital G, capital M, small m divided by capital R. Okay, now I am deleting this one. Okay, okay, then what is the v, from this equation we can cut m. Okay, so from this equation what is the ve? Ve square is equal to, we'll take 2 there, 2 into capital G, capital M, small m divide by R and divide by this m. Okay, so m to m will cancel out. So ve square is equal to 2gm divided by R. Okay, so what is the escape velocity from this equation? Ve is equal to under root 2g capital M divided by R. Okay, so this is an escape velocity formula of any for the earth, because this is the mass of the earth and the radius of the earth. So it is depending on the planet, biggest planet mass and its radius, means distance. Okay, so escape velocity is this. Now we will conclude this. We will calculate this value. What is the value is coming for this? Okay, so we will solve this equation in terms of small g, acceleration of the gravity. From this equation, we can calculate what is the force. Force is equal to mass of the object into acceleration, that g, small g. Okay, this is equal to force. Okay, mass of the object and earth gravitational acceleration. Okay, this we calculated. This is the only escape velocity, but we will find out this escape velocity in terms of the small g. Okay, because this small g we know as a 9.8 meter per second square. Okay, easily. Okay, so this we can write. So now this equation and this equation become equal. So small m g is equal to, we'll put f value here, capital G, capital M, small m divided by R square. Okay, so from here what is the value of g? G is equal to gm divided by R square. From m to m cancel out. Okay, so what is the value of earth gravitational acceleration? This, in the previous my video from the simple pendulum experiment, we have calculated the value of g. Okay, now here also we can calculate the value of g. We know this constant capital G, mass of the earth and radius of the earth. From that we can calculate the value of g. Okay, that is equal to 9.81 meter per second square after calculating. Okay, so now this equation we will put here only. Okay, so in this equation what we'll do, I am going to multiply by capital R and small r. Okay, both top and bottom. So this equation become VE is equal to 2 g m r divided by r square. Okay, then final value VE escape velocity is equal to under root gmr square. Gmr square we can write as a small g, and this is the r, radius of the earth. So my final equation become this in the terms of earth gravitational force. Okay, only we have to know the value of the radius of the earth and its gravitational acceleration. We can find out the earth escape velocity. Now we will calculate this velocity. Okay, so I think this you have note down. Okay, so we will calculate this value. So under this velocity is equal to under root 2 into g. G is, I told, 9.81 meter per second square, multiply by this radius, earth radius, multiply by radius of the earth. Radius of earth is 6.371 into 10 to the power 6 meter. Okay, so what is the escape velocity? You can say here, this is under root 2 into 9.81 multiplied by 6.371 into 10 to the power 6, and meter means meter square upon second square. I am writing the unit also here. Okay, so now we will calculate this value. So we will use the calculator. In the calculator, under root 2 into 9.81 multiply by 6.371. Okay, so this is coming 11.18 into 10 to the power 3. 1 meter means meter per second, VE. Okay, so this is coming 11.18 into 10 to the power 3 meter per second. Okay, we can write is in kilometer. So VE is equal to 11.18 10 to the power 3. We have to divide by 1000. Then it become kilometer per second. Okay, so now so this become kilometer per second. Okay, so the minimum escape velocity required for the rocket to escape from the earth gravitational force is 11.18 kilometer per second. Okay, this is the minimum velocity required to escape from the earth force. I think this is noted down. So if this is earth force of attraction and this is the rocket force of attraction, okay, and this is our earth. Okay, so to escape from the earth we have to require this much minimum force. You can give more also, but this thrust is required more fuels, more something. Okay, more energy. Okay, so this much to escaping this. So this much is the minimum. If you're giving more also, there is no problem. Okay, so if you're giving the more also, then it will easily escape. Okay, so this is the minimum. Maximum whatever is there, maximum is more than whatever the requirement, 11.18. more than if you give also, there is no problem, it will easily escape. Okay, but minimum is this much only. Okay, so this we have to require. Okay, so in this way we can derive the equation of Earth escape velocity. Okay, and we can calculate also the value of escape velocity of the rocket, because we are living in the Earth, so from the Earth only we have to escape. So for escaping me from the Earth, I want this much velocity, 11.18 kilometer per second. Okay, this much velocity if I will get, I can escape from the Earth very easily. Okay, I hope you will like this video. Please like and subscribe my channel so that I can give more physics videos also. Okay, thank you, bye.